Okay, part one of our online class is here, and let's do the last three problems. Now, problem number 9, I realized as I was recording that I did it wrong. I made a few silly mistakes, and I'm sure you guys noticed. This is 5 to negative 2. And originally, I think I thought it was 5 to 2. So let's take a look here. If we're going to have from 5 to negative 2, well, I want to change it from negative 2 to 5 because I know negative 2 to 2 and I know 2 to 5. So if I change this, it becomes negative. Or I change the 5 and negative 2, it becomes negative. And then I need to separate it into two different integrals. So I keep the negative sign out here, and I have negative 2 to 2 of f of x plus 2 to 5 of f of x. And I'm just going to be adding those together. That's going to be 4 plus 3, which is just up here. And that's going to equal negative 7 because the negative comes out front. Now with this problem here, the problem I did is I, for some reason, wrote a negative sign here, but it should be positive. So all I did was separate negative 2 to 5 to the f of x and the g of x here and here. And then I separated again because I needed to separate the f of x into two different pieces, negative 2 to 2 and 2 to 5. And in the end, I got 4 plus 3 plus 2 equals 9. Okay, next problem. This is a fun problem. Draw a function. So a lot of different answers could be here where you overestimate with the left-hand rectangular approximation. Now let's look what I ended up doing. You had to make sure that you had a negative slope because when we do a left-handed rectangle, let's take a look at this one. If I take a look at this interval and I choose the left-hand side, then it's going to overestimate the area out here. If I had some type of curve that was going up and I did an interval, let's say from here to here, then when I chose the left hand here, it would be an underestimate, right? So make sure you know what it's saying and what overestimate means. It means that the rectangle is going to be outside of the curve, or underestimating the area under the curve. Okay, the next problem. This problem is talking about the average value. And now when we're talking about the average value, we're going to have to take the integral of this on 0 to 3. So the only difference between not just the integral from 0 to 3 is because it says average here, we know that we're going to have to divide it by b minus a, or basically the distance of the x value. So when I take the integral of it, I end up getting not 4 but 4x, and not negative x squared but negative x cubed divided by 3 on the interval from 0 to 3. And I made sure this is all in parentheses because it's going to be divided by 3 or multiplied by 1 over 3 because it's the average value. Now when I do from 0 to 3, I have to plug in 3 into the x's and I get this. I plug in 0 to the x's and I get this. And obviously these are going to cancel out to 0. And this is going to reduce to 1. Okay, and for the last problem, let's read this. Refer to the region R in the first quadrant. Okay, so if we're going to talk about the first quadrant, that's going to be this quadrant here, okay, of this graph from 4x to minus x cubed. And what I realized is that it crosses the origin here, so it goes from 0, and when it has a 0 here, it crosses the x-axis at 2. So really we're talking about the area underneath this curve that I've shaded in here. So we're going to need to find 4 equal bases and compute the MRAM approximation. So I'm going to divide this up into 4 different spots, and this is what I end up doing here. And you'll notice that if it's from 0 to 2, I divide it into 4 things. We have from 0 to 0.5, 0.5 to 1, 1 to 1.5, and 1.5 to 2. Okay, I'm just going to write a little 2 here so you guys see what we are talking about. And then I had to find the midpoints here. And here are all the midpoints. 0.25 is here, 0.75 is here, 1.25 is here, 1.75 is here. I use the table function to get the y values here, or the heights of the rectangles in my calculator. So then after I found out these points, I said this rectangle is 0.5 times 0.984. This is 0.5 times 2.578, zero point 0.5 times 3.046, and 0.5 times 1.640 to find the area estimated with the MRAM. So when I did it out, I decided to add all these out, and I took out or undistributed the 0.5 because 0.5 was really multiplied by all of these. And then I plugged it in my calculator, and I got the estimated area of 4.124. Well, thank you for watching this video. I'm going to go back to the first slide here. If you watch the whole video, I want you to post in the comments section peanuts. If you can write the word peanuts, then I can know that you watched the whole video. So we will have a test in chapter 5 next week, and I'm going to assign some homework in the Google Drive. It'll just be the review section of the chapter. So don't forget to write peanuts in the comment section, and have a great weekend. Happy Father's Day.